Welcome to OpenNMS 101 again, Module 6, Part A, an Introduction to SNMP. SNMP is a protocol by which management information for network elements may be inspected or altered. OpenNMS only inspects, monitors management information. OpenNMS requests information and the network element responds with that information. The network element can limit the information it allows access to. SNMP requests are usually made through port 161. The network element status can be forwarded to OpenNMS through a trap. This will be discussed in another module. SNMP traps are normally sent to port 162. SNMP requests, responses, and traps use UDP. Install the following net-snmp packages on the server: net-snmp, net-snmp-agent-libs, net-snmp-libs, and net-snmp-utils. Net-snmp packages include various SNMP tools, an extensible agent, an SNMP library, tools for requesting or setting information from SNMP agents, and tools for generating and handling SNMP trap. Use system control enable snmp-d to enable the daemon, and use system control start snmp-d to start the daemon. net-snmp is up and running. SNMP makes use of management information base MIB files which describe objects in a network element. It uses the ASN.1 syntax. Network elements make use of generic and specific MIB files. SNMP implementations must provide support for GET request, which is the management station to controlled network element communication, GET next request, which again is the management station to controlled network element. This is useful for the traversal of conceptual tables of information within the MIB, a SET request, which is a management station to controlled network element, a GET response, which is the controlled network element to management station response, is generated by the receipt of the GET request, GET next request, or SET request, and trap, which is from a controlled element to a management station. Note that SET request has fallen into disuse for security reasons. The SNMP data types are integer, which can be a positive or negative 32-bit number, a counter, which represents a non-negative integer, which monotonically increases until it reaches a maximum value, when it wraps around and starts increasing again from 0. This can be a 32-bit or 64-bit number. A gauge, which is a non-negative integer, which may increase or decrease, but which latches at a maximum value. This can be 32 or 64-bit. An octet string, which represents any data type in a string of octets, and time ticks, which represents a non-negative integer which counts the time in hundredths of a second since some epoch. Temperature can be represented by an integer. Bits in or out can be represented by a counter. A percentage can be represented by a gauge, and uptime can be represented by time ticks. There are 3 versions of SNMP. Version 3 provides authentication, integrity, and encryption. Versions 1 and 2 do not. For that reason, use version 3. Version 2 should have very limited use. Version 1 should not be used. Objects within a network element are identified with an object ID, the OID. The OID is derived from the OID tree structure. Use the file user share snmp MIBs snmp v2-smi.txt to get an idea of the OID structure at the top. This is the SNMP OID treetop as derived from the snmp v2-smi.txt file. OpenNMS is shipped with the ability to monitor down the MIB2 path, the Experimental Multi-Source Discovery Protocol MSDP, and over 60 private network elements such as Bluecoat, Cisco, F5, and Juniper. On installation, OpenNMS can monitor these MIB2 network element objects. As already noted, OpenNMS can monitor the experimental MSDP. And this is the list of vendors that OpenNMS can monitor. Vendors may release new MIB files which can be integrated into OpenNMS. Private enterprise numbers are assigned through IANA, the Internet Assigned Numbers Authority. The web page is shown. Compare the OpenNMS private enterprise OIDs to the IANA assignments. The blue coat number in OpenNMS is 3417. IANA has assigned that number to Cashflow Inc. According to Wiki, Blue Coat was known as Cashflow until 2002. Cisco has the numbers 9, 522, and 3076. IANA has assigned 9 to Cisco Systems, 522 to Telesystems SLW. Cisco Aeronet started as Telesystems SLW. 3076 is assigned to Altiga Networks, which was acquired by Cisco. F5 has the number 3375, and that corresponds to the IANA assignment. The riverbed numbers also match between OpenNMS and IANA. Return to the server terminal and verify the SNMP agent is running by executing the net-snmp grep command given. This shows the SNMP daemon is running on port 161 on all interfaces and is using UDP. OpenNMS is already monitoring the SNMP service. This is happening because the self-monitor requisition is configured to detect the SNMP service. To verify this, click on Admin Configuration and then on Manage Provisioning Requisitions. Click on the pencil on the self-monitor line. Click on Edit Definition. One of the detectors is SNMP. Return to the localhost front page and click on the SNMP service. OpenNMS is polling the SNMP service and collecting SNMP metrics at intervals of 300,000 milliseconds, or 5 minutes. Return to the localhost front page. The SNMP collected metrics listing can be viewed by clicking on Resource Graphs. This is a very small number of metrics. This will be corrected. Return to the localhost front page. Make a note of the SNMP attributes: name, sysobject ID, location, contact, and description. Return to the terminal window and move to the opt OpenNMS etc subdirectory. And view snmp-config.xml. This file contains the connection parameters, IP, authentication, passphrase, and so on OpenNMS will use to connect to SNMP on a network element. The default connection as shown is to use SNMP version 2C and the community string public. This works because this is the default access method to the SNMP agent set up by installing the net-snmp package on Linux. Change directory to etc snmp. Execute the egrep command as shown. This command ignores comments and empty lines in the file snmpd.conf. snmpd.conf is the configuration file created by the net-snmp package installation for the SNMP daemon. The public community string is attached to the not-config user, who in turn is connected to the not-config group in both SNMP versions 1 and 2. One view, system view, is established and includes the OIDs shown. Access to that view is granted to the not-config group at the read level. The write privilege is not granted. The details of the system view included OIDs can be found by using snmp-translate. The command line is snmp-translate -lowercase m all -uppercase m user share snmp MIBs -uppercase T D and the OIDs. This will print detailed information about the OIDs. The first OID is the MIB2 system object. The second OID is the HR system uptime. The MIB2 system object likely has children. This is the ASN.1 syntax, the abstract syntax notation 1. This is the SNMP relevant information. The HR system uptime syntax is time ticks. The max access to this object is read-only. The status is current, and the description begins with the amount of time since the host was last initiated. The from line is the file in user share SNMP MIBs that stores the information, host-resources-mib.txt. snmptranslate can also be used to provide an ASCII tree of all the objects to which snmpd.conf allows access. Replace $T with $T P. The results fly by, but they are manageable to view. The system object includes sysdescription, sysObjectID, syscontact, sysname, syslocation, and a sysor table. The HR system uptime is at the bottom of the tree. snmpwalk can be used to retrieve information starting at some point in the SNMP hierarchy. Start at ISO.1. The limitation imposed by snmpd.conf through the system view configuration can be demonstrated by the following command: snmpwalk -v 2c -c public localhost .1 using SNMP version 2c and the community string public. Retrieve all SNMP data on the local host at or below the ISO level. This is not a lot of information. Certainly not as much as one would expect from a Linux server. The output matches what snmptranslate -T predicted. The limit is imposed by snmpd.conf to the MIB2 system branch and HR system uptime. Running snmpwalk through SNMP version 1 produces the same result. The only thing that changed was that SNMP access was through version 1. Scrolling back a bit, notice that the retrieved object information is the same as that for version 2c. Sysdescription, sysObjectID, syscontact, sysname, syslocation. The command is highlighted so that the version demarcation is clear. And at the bottom, HR system uptime. To summarize, OpenNMS can use SNMP to monitor network elements. The three key OpenNMS configuration elements are the data collection files, which define which network element objects OpenNMS knows about, the self-monitor requisition, which contains the OpenNMS server and provides the SNMP detector, the snmp-config.xml file, which provides a default access method to network elements. This is currently set to SNMP version 2c and the community string public. The Horizon server, acting as a network element, lists all of its available objects under /user/share/snmp/MIBs in numerous MIB files, and the SNMP agent is configured through /etc/snmp/snmpd.conf. snmpd.conf currently limits access to the network element objects and grants access to SNMP version 1 or version 2c. Up next, Module 6 continues with Part B, using SNMP v3 and opening up object access.